Now this is a probability workshop question number 7. Now before I start solving this question, I just want to take an example. Now suppose there is a bag in which there are say 1000 black balls and one red ball, right? An experiment is a ball is drawn from this bag, and we have to find probability ball drawn is red, probability red ball. Now if you apply classical definition of probability on this experiment, then we define sample space, because classical definition is we count how many elements in sample space, that becomes denominator, and numerator is the favorable outcomes. Now sample space, like the possibilities, when we draw a ball, what are the possibilities? When we draw a ball, there are two possibilities: either we'll get a red ball out of it or a black ball. There's no other possibility. Though there are 1000 red balls and 1000 black balls and one red ball, but sample space has two elements. And you know, classical definition of probability has limitations, in the sense that when we write sample space, we consider each element equiprobable. We write probability in such a way that we assume each element equiprobable. So we see there are two elements in sample space, and for red ball there is only one element that is favorable, so probability is half. And similarly, if we find probability of black ball, that is also half. So classical definition of probability, we can say, fails here. This example is not the right example to apply classical definition of probability, because the elements in the sample space are not equiprobable. We know when we draw a ball, red ball and black ball, they are not equiprobable, as there are 1000 black balls. So probability of taking out a black ball is much more than probability of a red ball. So this is not a right example to apply classical definition. Classical definition is the right approach when all the elements are equiprobable in the sample space. Now if we the right example is the axiom approach, but axiom approach is not in the ITJ syllabus, and it's not that easy that somebody can understand in some time. So the result, I'll just tell you the result that comes out of the axiom approach. And according to axiom approach, we can consider we should consider all identical items as different items. If there are 1000 black balls which are identical, we'll assume all black balls different. So in a bag there are 1001 balls, and we have to assume all of them are different. All black balls are different, and obviously red ball is also different. So probability of taking out a red ball is, there is one red ball that is favorable, and the total number of balls is 1001, and we are assuming here all the balls are different, and black ball is 1000 over 1001. Now if you just look at question number 7 of probability, so in this case we have to, like, from the letter word probability is given, and experiment is a letter is selected from the word probability, and we have to find that selected letter is a vowel. Probability that the letter we select from the letters of the word probability is a vowel. So if you just see the possibility in how many ways we can choose a letter in this case. So in this case again there is a problem. If you see, there are two b's are identical here, two I are identical here, so probability of getting a B out of this probability, or getting a probability B letter, should not be same as probability of P letter. So if you just try to write the sample space of it, all the elements are not equiprobable. Probability of getting B is not equiprobable to probability of getting R or Y. So again, this is an example where classical definition is not the approach. We follow axiom approach, and according to axiom approach, we have to assume all letters are different letters. So to the letters that favor vowel, which are vowels are like, there is O letter, A letter, I, and there is another I. So there are four letters, and we'll assume all of them are different. So there are four letters that are favorable, and out of total 11 letters, the probability should be 4 by 11.